And this is where we have to break the interval into two parts. Find the area bounded. Find the area of the region bounded. Let's see, y1 equals sine x, y2 equals cosine x, x1 equals 0, and x2 equals pi over 2. All right. So we're going to go from 0 to 1 on the y-axis as the sine and the cosine can carry only values from -1 to 1. And let's see, the sine, the first one, start at 0, and at pi over 2, let's make this pi over 2, we get to 1. So it's going to be like this. Okay. And then it starts coming down from this point on. So this will be y1 equals sine of x. The cosine of 0 is 1, cosine of pi over 2 is 0. So the curve looks like this. We continue at this point like so. So y2 equals cosine x, and we know that in the first quadrant, from 0 to pi over 2, cosine equals sine at pi over 4, both equal at this point, square root of 2 over 2. So this is pi over 4, and this value is the square root of 2 over 2, which is 1.7, something like that. This is square root of 2 over 2. It's 0.717, 0.707. Square root of 2 is 1.414, and square root of 2 over 2 is 0.707. Dot, dot, dot. So we're looking at area at A1 where the sine, the cosine is above the sine, okay? And we're looking at A2 where the sine is above the cosine. No, the area together is not. So what happened is we have the intersection, of course, at pi over 4, we established that. Just formally, let's write cosine x equals sine x, and this happened when x equals pi over 4. Okay? Or the way to do it is you look at the tangent. If you divide both sides by the cosine, you have tangent x equals 1. You can write, or tangent x equals cotangent x equals 1, and then x equals pi over 4. However you want to slice it, it is like that. And we're going to say the area is the area as A1, the area to the left of the intersection past the area of the right of the intersection. And the reason we break it down is to the left of the intersection, A1, we going to have the integral from 0 to pi over 4, where y2 is greater than y1. So we'll go y2 minus y1 dx. And A2, we're going to integrate from the intersection of pi over 4 to pi over 2. And in this area, y1 is greater than 1, 2. y2, so we go y1 minus y2 dx. Okay, and that's why we broke it down. The other thing that you may want to assume, is it possible, would it be right to assume that the area to the left equals the area to the right and just do 1/2 and double by 2? Well, I'm not so sure. So because I'm not so sure, because sine and cosine, one is even, one is odd function. The sine is odd function, the cosine is even function. I'm not sure that the difference, plus we're talking about symmetry about pi over 4, not about, I'm sorry, not about, symmetry about pi over 4, not about the x. So the rule of symmetry, I'm not so sure whether they're applicable in this case or not. So I'll just integrate one area. I'm going to find one area at a time. And at the end, we'll be able to tell whether A1 indeed equals to A2. So A1, the integral from 0 to pi over 4, in A1 we're looking at y2 minus y1 dx, or recall that y2 is the cosine. So we look at the cosine minus the sine, and we go from 0 to pi over 4. So antiderivative time, or the antiderivative of the cosine is the sine. The antiderivative of the sine is the negative cosine. So because we have negative sine, we'll have plus cosine. Again, the rationale. You take the derivative of the sine is the cosine, so the antiderivative of the cosine is the sine. If the derivative of the cosine is negative sine, so the antiderivative of negative sine is positive cosine. And we evaluate from 0 to pi over 4. So at pi over 4, we have square root of 2 over 2 plus square root of 2 over 2. At 0, we have sine of 0, 0, and sine of cosine is 1, so we have 0 plus 1. So we have square root of 2 minus 1. So this is A1. A2, and the integral from pi over 4 to pi over 2, and now y1 is above y2. So we have the sine first and the cosine next. Okay. So check the antiderivative. The antiderivative of the sine is the negative cosine. The antiderivative of the cosine is the sine, so we have negative cosine. So both terms are negative in this case. Evaluate from pi over 4 to pi over 2. I can keep the negative, or I can take the positive and flip stuff over. I'll keep it like that. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so we have 0 minus 1. Minus pi over 4, cosine of pi over 4 is square root of 2 over 2, so we have minus square root of 2 over 2. And the sine is 1. So we have negative 1, and we have plus square root of 2. So indeed, we have symmetry. So the conclusion is we could have gone only one side, A1, and double it. So we do have a symmetry in the area, A1 plus A2 is 2 times the quantity square root of 2 minus 1. Okay, so here's the observation. So in this case, the result indicate an even symmetry about x equals pi over 4. So we can write, this is therefore this triangle. I don't know if you saw it last semester. Therefore, the area is twice okay?